Uh, uh, Hi, I am Sungmin Sung, and I will show you a demo of my lab assignment 5. As I have mentioned in previous labs, this is a machine learning dataset that is used for age prediction. Therefore, I have made a dashboard that can show interesting correlation with key variable age. So I'm going to explain the reason why each type of visualization is implemented in the dashboard. Firstly, I chose a bar chart or histogram for the distribution of categories or bins of variables. Secondly, I implemented Heatmap to show how much each category or bin is distributed with respect to the age groups. So the age groups are placed in y-axis and the other variable is going to be on the x-axis. Thirdly, I have implemented the biplot to show the contribution of each variable to the variance of each primary components. And lastly, I chose parallel coordinate display to show the important variables that is highly correlated to each other. As you can see, there's again a drop-down menu to select variables that is used for bar chart and histogram and the heat map. Uh, as I have mentioned, heat map's y-axis is fixed as age and divided into groups, and changing variable from the drop-down menu will change the variable in the y-x-axis. So let me show you a change in selected variable is working fine for other variables too. So as you have seen, the drop-down menu change is updating the corresponding data for bar chart, histogram, and heat map variable. And let's move on to the data brushing and linking interactions. I chose a selection in bar chart or histogram that highlights the corresponding data points or lines for biplot and PCD. So if I click the categories here, it updates the corresponding data points or lines in the visualization on the right-hand side. So if I change the variable and select bins, for example, 8 here, then the corresponding points and the lines are again highlighted very well. And let's move on to the other technique, which is brushable biplot and PCD. To elaborate, if you brush any position of the biplot or PCD, it highlights the corresponding points or lines on the other display. So if I want to see the points with the high H, as you can see, the H vector is here. So if I brush here, and the corresponding lines in PCDs are highlighted. And also it shows that data with the high value of age is highlighted. And if you click outside, it is disappears. Or if you brush in the PCD, it also deletes the brush in biplot and updates the corresponding highlighted points or lines. Yeah. And furthermore, it works well even after the selection from other visualization that I have previously showed you. So if you want to look at, let's say, bone dense vision sharpness data. So let's select some high bends, which will be placed on the left-hand side of the biplot, since the bone density vector is showing negative correlation with the PC. So as you can see, the highlighted points and lines, if you brush it, the selected bins are uh, not reset, so it is saved well, and then you can see the corresponding lights, uh, corresponding lines and points very well. And if you click the other part, the selected variables are saved very well. It doesn't disappear. So let's move on to the essence of my data visualization. Okay. So the interesting relationship shown in my data visualization will be the first as positive relationships with the key variable age. If you look at the biplot, the age vector is projected towards the right side of the PC1, along with the systolic, diastolic blood pressure, and hearing ability. So which means it is showing uh, positive correlation with the primary components one. And if you let's go to see the uh, let's look at the systolic blood pressure. So if you click the systolic blood pressure on the drop-down menu, you will be looking at the heat map. It's looking like a y equals x graph. So so do the diastolic blood pressure. It is looking like a y equals x graph. And so thus the hearing ability. So if I highlight the bins that have high values for the hearing ability, uh, this will be enough. So it is placed on the right-hand side, which is looking very well. And if you look at the PCD, the highlighted lines are showing high values of hearing ability and which is connected to the high values of age, as you can see here. If I brush, this isn't better looking. So this is implying the positive correlation between the variables with respect to age. And then the second interesting one is, of course, negative relationship shown in the visualization. If you look at the biplot, the bone density and vision sharpness vectors are projected towards left side of the PC. So let's look at the bone density and the vision sharpness. If you in the heat map for vision sharpness, it looks like a y equals x graph. So does the bone density and um, yeah. Again, if I highlight the high values for our bins, it is projected in the left-hand side of the biplot and showing high values of vision sharpness and high values of bone density with the low values of age. So if I brush it here, it looks more vivid. So this is implying the negative correlation between the variables with respect to age. So to summarize the demo, through the visualization labs, uh, 4 of my 5 hypotheses that I've made in lab 1 is either rejected or accepted. I guess blood pressure, bone density, hearing ability, and cognitive function are going to have negative correlation with the age. But I realized my hypothesis for bone density and cognitive function were correct. But blood pressure and hearing ability were rejected. So let's go to see cognitive function. So I guess the cognitive function will be have negative correlation with the age. So it is looking like a y equals minus x graph in the heat map. And if you click the high values in the cognitive function, it is showing that is connected to the low values of age, right? And um yeah. And the reason why my hypothesis for blood pressure and hearing ability is rejected is because If you look at the hearing ability, it is showing y equals x graph. Is because I thought the hearing ability is in terms of range, but it was maybe the minimum size of sound in decibels. Therefore, it increases in decibels with respect to age group, since the older people are not able to hear uh, smaller sounds. So yeah, the decibel should be increasing, and therefore it is showing positive correlation with age in this case. And I think this is the end of my demo of my lab assignment 5. And I really appreciate watching my demo and guiding me during the semester. I wish you best luck with your future, and thank you for listening.